In a world powered by devices, the real hero works silently behind the screen, the operating system. But why does your smartwatch look so different from your school computer? Why can a gaming console handle action-packed graphics while a space robot makes real-time decisions millions of kilometers away?
Hey everyone, Ozzie here. I'm back. It's time to dig a little deeper into my world of operating systems.
Let's explore how each type works, where it is used, and why it matters in the simplest way possible. Let's go back to the 1950s. No screens, no keyboards, just punch cards and batch jobs. Batch OS executes jobs in groups without user interaction. You submit a task, wait, and then you get your result later. These were used in the early mainframes for payroll, bank reports, and scientific calculations.
I don't ask questions. I just take the whole stack, finish it, then give you all the results.
Imagine a bustling computer lab or even a giant server in the cloud, where not just one, but many people are trying to use the same powerful computer at the exact same time. Each person wants to run their programs, type commands, and get instant feedback. How does one computer handle all of that? That's where time sharing comes in. Instead of giving one user the entire computer until they are done, a time sharing OS works like a super efficient ringmaster, or in our visual, Ozzie as the ultimate host.
It's like a grand illusion. Each user thinks they're the star, but I'm just incredibly fast at sharing the spotlight.
So now let's learn about multiprogramming operating systems, which are all about efficiency. Imagine you start a long document printing. While your printer slowly chugs along, what's your computer CPU doing? Is it just sitting there idle, waiting? A multiprogramming OS hates to waste valuable CPU time.
Waiting? For a printer? Not on my watch. While one program waits for slow I/O, I instantly give the CPU to another program that's ready to run.
Exactly. The OS rapidly performs a context switch, ensuring the CPU is always busy and productive. Now let's look at something we all use every day: multitasking operating system. Think about your phone or computer right now. You might be playing music, downloading a file, and texting a friend, all seemingly at the same time. This is the magic of multitasking. A multitasking OS allows a single user to run many different applications or tasks all at once.
I cook multiple dishes simultaneously. Each app gets a quick turn on the CPU, switching pans in milliseconds.
The rapid context switching is the key. It is so fast, your apps appear to run concurrently, giving you a smooth, uninterrupted experience across everything you are doing. Now let's imagine a world where every single action, every single task absolutely must happen at a precise moment. There is no room for delay, no tolerance for a task finishing a little late. That's the world of real-time operating system. Here we see our friend Ozzie in action, managing a high-speed assembly line. Each glowing component on this conveyor belt represents a task in a real-time OS. The belt itself, moving at an unchangeable speed, symbolizes the strict deadlines these tasks operate under.
Exactly. In a car, my timing must be perfect. An airbag deploys, ABS brakes respond. There's no maybe later. I guarantee it's on time, every time.
When many computers need to connect and share resources like printers or files, you need a central manager. That's network operating system.
Welcome to the network. I'm your dedicated manager. Files, printing, apps, I've got it covered.
The NOS acts as the central boss, allowing independent computers to communicate, share, and collaborate efficiently.
Smooth communication, secure logins, seamless resource access for everyone on the team.
Think of an office server managing all your shared files and printers. That's the power of a network OS, bringing order and efficiency to all your connected devices. What if many computers could work together as one giant, super intelligent system? That's the power of distributed operating systems.
I clone myself across machines. Each Ozzie handles a piece of the puzzle, all working in sync.
A distributed OS coordinates numerous independent computers, making them appear and function as a single unified system. This means incredible scalability and reliability. Think of the massive power behind cloud services like Google Cloud or AWS. They all rely on distributed OS to deliver immense computing capabilities. Every operating system has its own superpower. Time to recap how each one keeps our digital world running smoothly. If this video helped you understand operating systems better, give it a thumbs up, drop your questions in the comments, and subscribe to follow Ozzie in the next episode. Thank you so much.